Okay, today I'm going to talk to you about density. So density is basically a measure of how compact a substance is. So how tightly packed together the particles are. So I'm going to use an example to illustrate this idea. So let's imagine I have two cubes. One of those cubes is 1 centimetre cubed in volume and it's made of iron. And let's imagine the other one is jelly, but also has a volume of 1 centimetre cubed. So what we can do is, I'm going to show, if we just imagine I'm looking really close up at a particular section of this on an atomic level, I could see what the particles would look like in the iron. Now iron has a high density, so we can see all the particles are really closely packed together. If I have a look at this enlarged diagram, so again on an atomic level of the jelly, we might see that the particles are much less tightly packed together. So as we can see, the iron has a higher density than the jelly because we can fit more particles within the same volume. As a result, if I measured the mass of these two, I might find that the iron has a mass of around 8 grams and the jelly has a mass of around 2 grams. This is despite having the same volume, and this is just due to the fact that the iron has a higher density. The particles are more tightly packed together. So there's an equation that we need to understand to get our heads around density, and it's a really nice simple equation. Density equals mass divided by volume. So what we're going to do now is we're just going to quickly have a look at these two specific examples of iron and jelly in order to find the density of these two substances. So firstly, with iron, the density equals the object's mass, and in this case the mass of the iron is 8 grams divided by its volume, and in this case it's 1 centimetre cubed. Now, in order to find out the units for density, we do it like this. So first of all, 8 divided by 1 is 8. To find the units, we need to look at the mass and the volume. So this is grams over centimetres cubed. So the units are grams per centimetres cubed. Remember, this per means divided by. So it's grams divided by centimetres cubed. So it's per, grams per centimetre cubed. Similarly, if we have a look at the jelly, it works in exactly the same way to find the density. So again, we want to do mass divided by volume. This time the mass of the jelly is 2 centimetres cubed, 2 grams even, and the volume is 1 centimetre cubed. So just like before, we do mass divided by volume, so 2 divided by 1 is 2, and the units are going to be grams per centimetre cubed. Right, I just want to quickly show you a slightly different example in case we had a different object. So let's imagine we had an object that had a mass of 10 kilograms, and let's say it had a volume of 5 meters cubed. Now, in order to find the units for density for this one, again, we do mass divided by volume, so 10 divided by 5 is 2. But to find the units, this time it's kilograms per meter cubed. So we're going to write it like this. So to find the units for density, it's always mass per volume. So we need to look carefully at which units we're dealing with here. The final thing that we're going to look at is how we can use information about density to figure out whether an object would float or whether it would sink. So the density of water, pure water, is 1 gram per centimetre cubed. So let's imagine this here is some water. Now, if I got my iron cube, as we can see, the iron has a higher density than water. So as a result, If I put this iron on the water, it would sink because it's got a higher density. However, if I had a different substance, for example, a type of wood called pine, so here's my pine, that has a density of around 0.5 grams per centimetre cubed. As you can see, this is a lower density than water, so therefore it would float rather than sinking. So, hopefully now we know what density is, how to use the equation and find the units of density, and how we could use information about density to find out whether objects float or sink. Thank you.